All right, examples 2 says, find d squared y over dx squared. What this is telling us to do is find the second derivative. It's an equivalent notation to y double prime. So just so you guys know, they mean the same thing. Where y squared minus x times y equals 8. So we're going to find first, in order to find our second derivative, we got to find our first derivative. I would be cautious because I have x and y's mixed here, you guys. So this is really a product rule because it's x times y. So let's go ahead and take the derivative of this to find the first derivative, then we'll find our second derivative. So I'm taking the derivative of y squared. So I would have 2y. I took the derivative of a y, so I must write dy dx. Minus, now I'm going to do the product rule of this, and so I'm just going to put it in parentheses for now and then distribute my negative later. Okay, so product rule, derivative of your first, x, times the derivative of my second. Well, the derivative of y is 1, so it'd be times 1, and then you took your derivative of y, so it's dy dx. Okay, so first times the derivative of the second, plus my second, y, times the derivative of my first. Derivative of x is 1. It's a times. Equals derivative of 8, 0. Okay. Now I'm going to distribute my negative, so I'd have 2y dy dx. And then I'd have minus x dy dx minus y equals 0. And now my goal is to get dy dx by itself. There are 2 dy dx's, so what I would do is get them onto one side of the equation. So I'm going to leave them on the left-hand side and everything else to the other side. So I'm going to add y to the other side. So I have 2y dy dx minus x dy dx equals y. And then from here I would factor out my dy dx. So I have 2y minus x equals y. And then to get dy dx by itself, I would divide both sides by 2y minus x. Okay, so this is my first derivative. Now, in order to find my second derivative, I'm going to take the derivative again, and in this case, it's going to be a product rule. I am going to quickly, though, take this on the next slide. Okay, so here's my first derivative. Now to find my second derivative. I do quotient rule, so low, d high. The derivative of my numerator is 1, and then since I took the derivative of y, I must write dy dx. So low d high minus high. Now take the derivative of my low. The derivative of 2y would be 2, but I took a derivative of y, so I must write dy dx. Minus the derivative of x is 1. All over our low. Okay. And now I'm going to go ahead and simplify. Same idea here, you guys. You cannot have your dy dx. Okay, left in there. So I need to sub in this for my dy dx. Okay, so I'm going to go ahead and do that now. Taking this, plugging it in here and here. Okay, so y double prime equals 2y minus x. Now I'm rewriting what dy dx is. So I'd have y over 2y minus x minus y. And then I have 2, plugging in what my dy dx is. Y over 2y minus x minus 1 all over your 2y minus x squared. Now from here I would look for things to simplify. Thankfully those two things cancel, so that's super nice. Otherwise over here I would distribute my negative y. It's not looking like it's going to simplify super nice, but let's just see what we have. We got y double prime equals, I have y here. Now I'm going to distribute my negative y, okay? And this 2 really belongs with this, so I'm going to write this as 2y right there. Distribute my negative y. So I'd have minus 2y squared over 2y minus x. And then I would distribute this negative y here, so I'd have plus y. All over that common denominator. Not the common denominator, all over my low. That's what I want to say. Then I'm going to combine line terms. I have y plus y, so I'd have 2y in my numerator. Okay, so this is all in parentheses, and I'm going to multiply by this reciprocal. So this is going to become 2y. So I'd have 2y minus 2y squared all over 2y minus x all over 2y minus x squared. Same thing as I did in the last one. I'm going to multiply by this reciprocal, so 1 over that. So y double prime I'd have 2y minus 2y squared all over 2y minus x. So there's the numerator times this. So I'd have 2y minus x squared. So I would distribute that to both sets here. So y double prime, my second derivative would be 2y all over 2y minus x squared minus 2y squared all over 2y minus x. This is to the first power times 2, so to the third. Okay. And this is a good answer. You could leave it just like this. The other thing you guys could go ahead and do if you wanted to, so this is a good answer. The other thing is you could get a common denominator. So I'd have to multiply this one by 2y minus x. I'm going to quickly take that to the next slide. So this is a good answer. The other answer that would be acceptable is if you got a common denominator. So what I would need to do, take this one times 2y minus x. So my other answer would be 2y minus x. So third in the denominator, I would distribute this. So I'd have 2y squared minus 2xy minus, ooh, this actually simplifies a lot nicer than I thought it did originally. Ooh, I made a silly mistake. 2y times 2y is 4. There we go. Double check. There we go. Then distribute that. There you go. So then these two would simplify to 2y squared minus 2xy all over 2y minus x to the third. This would also be a good answer. Okay, so the one in green or this final one, those are both good answers for our second derivative.